Well, hello and welcome back to Introduction to Robotics. This is John Steele, and I'm going to continue with my presentation on the course and what we're going to do this semester. And if you haven't seen the initial introductory video, you might want to look at that first. But on today's discussion lecture, I'm going to talk about really what the course is about. You may recall from the other video that I sort of finished off with saying, so what are we going to study? Remember that robots are really the best example, I think, of mechatronic systems. And mechatronic systems are made up of subsystems that include electrical and electronics, mechanical subsystems, and software. And software is really the elixir that makes it all work together. But in any case, I talked about these different topics within each of those subtopics that we're going to cover. And so that's what we're going to be doing. Here's what we're really going to do, as it were, for the semester. We're going to read some reference materials. There is no textbook for this course. There are only my notes and these lecture videos now and the activities that are in the lab, along with references to external information. So, for example, one of the things I want you to learn how to do is read a data sheet and use it to develop an understanding of a particular device. So that's what I mean by reference materials. You're also going to design and build Lego robots, robots out of Legos using the modern style of Legos. You're going to use sensors. You're going to wire up circuits that involve a few different kinds of sensors, including contact sensors and IR sensors and other sensors, and encoders, brake beam sensors as they're called, and you're going to characterize their performance. And then overall what you're going to do is projects. So there are a number of projects. We're going to talk about those in a minute. But in those projects, you're going to write code, you're going to develop problem-solving strategies, and at the bottom I say we're going to compete. I mean that in the kindest, gentlest way. That is, each of these projects involves some sort of activity, and how well your robot does is documented in your report. And so I do pay attention to that in the grading, and the idea is that it gives the student teams a little incentive to work even harder to do a great job. Okay, so here's how the grading goes for the course. As you can see, it's weighted very heavily towards the projects. Again, I'm a big fan of and believe in hands-on learning, and so this course is about hands-on learning. You're going to spend more than 3 hours a week in lab, as you'll find out. It's scheduled for 3 hours, but by and large, these projects will demand, I'll call it, significant time outside the regular hours. The good news there is that you have access to the lab, which is W220 24/7 via your blaster card. Now that privilege is contingent on everybody behaving like adults and conducting themselves in a professional manner. If at any time there's a problem with the cleanliness in the lab, or if people are doing things that are unsafe or inappropriate, then at the flick of the switch, the lock will be dropped and there won't be any access. So clearly you have to act like adults and be professional about your behavior there. And as long as you do that, everything will be fine, and you'll have full run of the place for the whole semester. Okay, so that's the lab kind of side of things. Then there's homework and quizzes, and these will be things that you'll be asked to do outside of class, and then they're really going to be online. There are two exams, and there's one in the midterm and one in final, but they're both weighed the same. There's something I call Robot of the Week, and we'll talk about that more, but basically each team gets to come up and present to the class information about a really cool robot that they found. And I'll give you more information, but the short version is it has to be a real robot, and you have to be able to talk about its technical aspects. And last but not least, there's a score for attendance and participation, and by that I mean you got to show up. Just like work, you got to be here. And it's particularly important because of the project aspect and the fact that there's so much time spent in the lab. I want you to be here, and I want you to learn, and you're going to do that by working on your projects with your teammate in the lab. So that's a big deal. And participation just indicates that you are actively engaged in the course and conducting yourself in a professional manner. So those are the ways you gain points, and everybody can do really well in this course if you just work at it. So what are my expectations? As I said, attendance. I expect you to show up, and in fact I will take a role essentially every class and every lab, and one way to get in trouble is to not show up. On the other hand, all you have to do is show up, and it's worth more than 50%. So that's a good thing. And participation, really, again, the idea here is for you to learn about robotics by doing stuff. And so while it's easy for teams to fall into a mode where member A is the coder and member B is the robot builder, that doesn't really balance out your skills on an individual level, and so it's important for you to participate by interacting and trading tasks and trading responsibilities back and forth, and I'll do my best to help you with that. But basically you want to make sure that you come out of the course being able to build robots and deal with circuits and soldering and testing and that sort of thing, as well as being able to write software. So it's all important. As it says there, projects are 50% of the grade. 50% is based on the report. So every report has a format, and as a team, you guys write up a report, and then in that report, you will document your performance. Depends on the particular project, what is being asked of you, but you'll provide those results. And we do use those results to evaluate the quality of your performance, and that's included in the grade. Basically, we just use that as a ranking system. But it's important to remember that this is a kindly, gentler competition, and everybody wins. So don't be overly concerned about that. And in particular, I really don't want to see teams not being helpful to each other. So the more you can help your peers in the course, the better we all are. We all learn from that, and that's really important to me, that you really work at that. Okay. And then there's this homework and quizzes, and that'll be done online. It's via Blackboard, and I'll talk about that more. The exams, there are 2 exams. I have them the second one will be during finals week, but it's just exam 2. And the first exam will be about the middle of the course. I have it tentatively scheduled on this schedule you see. One of the best things about this course is what I call the robot show, and on the last lab periods of the semester, we'll have a show, and you get to design and build your very own creation, and then show it off to the rest of the class and to the rest of the folks there. And this is always really fun, and there's always some amazing robots. So you can start looking forward to that. And what goes with that, of course, is have fun. If you're having fun, then you're going to be learning. And I think it's really important for us to make all of this as enjoyable as possible. There's no reason it can't be. Okay, so those are my expectations. What are yours? Well, maybe you want a good grade. I haven't met a student yet who didn't want a good grade. And so I'm going to help you with that. Basically, you all have A's right at this point, so just keep it up. The second thing, learn a lot about robots. Well, I think this is a great way to get introduced to the topic of robots by actually building them and programming them and seeing how they work. It's a lot better than reading a book, in my opinion, and so that's what it's all about. And I think you're going to come away with a lot of knowledge that you can use. As I said, robots are mechatronic systems, and so within mechanics and electronics and software, there are lots of opportunities for you to develop more knowledge and expertise. And one of the things that this course, this hands-on approach really does is it gives you a chance to develop these skills, which are very, very much a part of being a good engineer, in my opinion. And so you really will get a chance to practice this stuff. And one of the neat things that happens as a result of that is this idea of building your self-confidence. If you can actually build that robot and make it go through the maze, wow, what a great capability that is, and you should be proud of yourself for being able to do that. So I think hands-on learning and the corresponding recognition of progress is wonderful.